last curry I had was I had a vegetable madras, which was actually did I have? I think the last one I had was actually king prawn madras. The prawns were kind of overdone, but the madras bit was nice, very spicy. Oh yeah, I need to actually turn the music. It's coming through a little strong. Yeah. Okay, so the music's more reasonable volume now. It's down there. My mic's up here. Yeah, so the chances are you didn't hear much of that waffling. The webcam should hopefully stay out of the way, I think. I don't need full cam boy on. But hang on a minute, what's that capturing? Is that just capturing... oh, and it has got a screen capture as well. Perfect. Okay. So, that's for... We'll go for it, I suppose. 6 minutes in, we're about to set up. So, what's this? Oh yeah, okay, so I've got an interview on Tuesday for a what's the role? It's a support role. So it's not 100% what I was hoping to get, but it'll be better than nothing. And it's in a company that I've applied for a different role, so maybe I'll be able to kind of move about in that company. I don't know. But anyway, where we left off yesterday was with this lovely program. Actually, I'll tell you what, I think I did this off stream actually. Yeah, I think I did because Kalimian gave me a suggestion about that overwriting of the array thing. He suggested that I look up, that I print out where, that I print out the addresses of various things. So yeah, I don't actually have the source for this anymore because I removed it. But what he was suggesting was that I can print out the address of the last element in the array, and then print out the address of the variable which I declared like previously in the source. So I think that's what I've tried to do here. And I suppose, honestly, we can just do that again, I suppose, because it's all practice, isn't it? Actually, I don't do that, do I? What new job was it? Support? Yeah, it's a support role. So I'll show you exactly what it is. It's in fact, I've got this, haven't I? Ticketing technical support consultant is the role. It's at Advanced Computer Software Group. So yeah, basically what they do is they make software for they make ticketing software. So like Ticketmaster or whatever else you can sort of think of. Those kinds of websites, they make the software that powers those websites. So it's like it's a competitor to Ticketmaster basically, and the role will be offering support to the owners of those websites basically, or to the to the IT department for those websites. The ticket, the kind of events that they do it for is these things. It's like sports things, Premier League, rugby, international sports. They did mention cricket. So yeah, it basically will be me on the phones, I think, receiving phone calls. Yeah, provide excellent telephone support to customers. On occasional on-site supporters, sports clubs, join events. Yeah, I mean, sure. So yeah, that's basically it. So you do have your hands in the code. I'm not sure I do actually, really. Or do I? No, actually. Maybe actually, yeah, because it's work engineering to configure, test and deploy software to the specification. So yeah, there is testing involved, which is what I was going for originally. I was trying to get a junior testing role. Strong problem-solving ability. Oh, that's true actually. Yeah, I'm saying they've even at programming language and ASP. Don't know. Support and fix bugs. Yeah. Yeah. So I suppose it's not strictly just support. It is, but yeah, support and fix bugs. So yeah, that's roughly it. I mean, obviously, I'm describing it terribly, so I'll have to properly um, properly read this and remember it all. Proactively learn new areas of available software. Yeah, I mean, one thing I've been thinking of actually is it's something we were talking about in Seattle. It was the yeah, cheers, man, cheers. It was, I don't know if you remember, we were talking about documentation writing, and you were making the point that it's tough for the developers to write the documentation because they're kind of because they're so involved in the code and they know it so well that they can like lose sight of the basics, I suppose, and take a lot of things for granted. Whereas somebody who hasn't developed on it might have a better perspective and be able to like support people a bit better. So that's the kind of position that I'm in, really, not being a developer. I would be one of those people who's sort of learning the software, and sort of providing that link between developer and user, I think. So I'm going to try and get that point in the interview, that I'll be ideally placed to offer that support. So yeah, that's that. Right, this is what I have to do, isn't it? CD, git, Miblo, practice. Yeah, I've also actually watched back the last couple of streams and heard the mic quality. I know that it sounds absolutely awful, but I'm hoping to like buy some new gear soon, so hopefully the streams were a bit more watchable. I don't want to practice see. That's all I need. Okay. So I've managed to do that again. One of these days I won't have to do that practice printer thing. So let's set this up again. Mild curry. What a masala, okay. What chili is it in? Yeah. God, yeah, I mean, the thing I had at 7-star Szechuan had loads of chilies in. It was, it had a kung pao. I knew that it was supposed to be, that it is a kind of a spicy thing. But I had one of those chilies and it was just like, it was like hiccup hell is what it was. So I had to sort of give them a miss. Oops. Get my git very syntax experiments. So result equals 1. Let me set up the loop, I think. Was 0. Where's the experiment? X plus I. Nope. Expected identifier. Expected identifier or close brackets. Yeah. Oh God, what's that? Hello, Rosie. Good to see you. So I'm just practicing again. I think this might be the first stream that you've caught me when I'm practicing, as opposed to annotating. For the last few ones, I've just been doing the same thing, basically. I've written a function. This thing here is a function. I'll just show you one by one. So this here is a function. It's currently got an error in it. Is it just that? Picking out the chilies? Yeah, I just worked around my chilies. So yeah, I'm sure I left quite a lot of that meal actually. In some ways, I kind of wish I'd gone for the was it Dum Dum Noodles? It was one of the things that Casey recommended. Because I remember, I think Andrew ordered that, and the waiter asked him if he wanted it with meat. I mean, I'd already ordered, but I kind of thought, well, I could have gone for that, like, without the meat. But I didn't, so. Dan noodles, right. Ah, right. Wow, okay. Yeah, I should have gone for that. should have done that. Something equals power. This is going to be a float. And then we're going to print should choose a colour. Yeah, colours are the mildest ones, I think, aren't they? So, oh, it's worked. Get in. In fact, I can just test this even more. It's not that, it's that, isn't it? Alright, cool, so I'm remembering this stuff. This function is definitely correct now. So, Rosie, I can just talk you through what this function actually does. It's a power function. So the idea of this function is that you can pass the base to it. Oops. You can pass the base to it, which is like, say for example, you wanted to find, if you wanted to find like 2 to the power 3. Okay, so that's 2 times 2 times 2, which is 8. 2 would be the base, and the exponent is 3, because that is the number that you're multiplying the base by. Rosie likes it hot. He makes a mental note. Rosie's preference for hot curries. Sour chili flour. No. Crazy curry place. So I just listened to the entirety of the Limbo soundtrack there. Could do something long, couldn't we, really? I'll tell you what, let's get Antichamber on. It's quite long and it's quite gorgeous. That's going to last us for, oh my god, it's going to be an hour and 34. I think that might be a bit too long, actually. I think Mirror Moon is, I think that is quite long as well. So that's an hour and 10. I think that's a more reasonable length. Okay, yeah, so this power function is, you can pass the base to it, which can be a float, and a float is a number that can have, basically it can have decimal points after it. So you can do here, you can do 2.4, and then you can find, tell you what, I need to actually give it some more. Oh yeah, of course. So let's just let calc do it. So calc 2.4 is 13.824. It's actually 3 decimal places there, so I'll have to crank that up. If I just build this, oh man. Can I just? So that is what I want. Okay. So let's build it and let's run practice. And sure enough, 13.824 is what my thing is calculated. So what it does, it first of all sets the result to be 1. The result is the thing that it sends back. So by default it's going to send back 1. And then what we have here is a for loop. So in this loop I just want to iterate over, it's the number, so pass as the exponent. So I'm passing the exponent here, right? So if I pass a 3 as the exponent, then what will happen is it'll call this routine, it'll go into this loop. Well, it'll call the function, and first of all it'll set a float, it'll set the result to be 1. And then it will enter the loop, and we will see that I will be 0, and while I is less than the exponent, yeah, well, yeah, I mean partly, I could talk this through to actually solidify it in my own mind, right, so, humour me for a little while. So while I is less than the exponent, and we're saying that we're passing 3 as the exponent, right? We're going to go into the loop, we're going to do result times equal to base. If I just keep heading towards the sound of my voice. Keep heading towards the sound of my yeah. So while the exponent, while I is less than the exponent, right? So I is going to be less than the exponent at this point. Gosh, I'm sure that pun is a lot funnier than I'm actually understanding it as being. Keep heading towards the sound of my voice. Yeah, I mean, I've got a bad relationship as well. I'm not so great at 1, coming up with them, and 2, 2, understanding them. You've been yes, you've been a darling, humouring me. And this is Oatly, by the way. This is what we're drinking tonight. So while I is less than the exponent 3, we're going to do result times equal to the base. So the result we previously had as 1. We saw the result was 1. We times and equal the base, right? And the base is 2.4. Tell you what, actually, rather than me actually talking it through, we can literally do this, can't we? We can. God, I said I was lost. Yeah. You know what? This probably counts as. This counts as one of those things. Give me an example of a time when you've explained something technical in layman's terms. So if I can manage to do this, then I will have a good example to give at my interview next Tuesday. And at the moment I'm not sure that I'm doing a very good job of it. Where would be a good place to break there? I wonder if I could break. I need to break on line 23, I think. Sorry, line 8. I think I need to break there. Probably not even run. So we're going to run. Source file's more recently executable, is it? Right, okay. I'm not going to touch that anymore. GDB practice, we're going to break out line 8 and run. So over here, can we print out, is it the result that I want printing? Yeah, so we've entered the loop. Result is equal to that. Yeah, but how can I put this? Well, okay. You can be. I'll try and explain it to myself, right? And you can be a bystander. You can just enjoy watching me and listening to me. So this is the first time through the loop, right? The result is 1, and it's set these things up. If I continue to the next iteration and print result, hopefully the result is going to be 2.4, and it is. Yeah, Faraday, yeah, Faraday probably does, because Faraday is a genius. So the first time through the loop, I'm explaining. So I is still. Is that a really good thing? Yeah, I think it's a good thing. Yeah, I mean it requires powers of logic, doesn't it? So I think it's a good thing to be able to understand this stuff. So this iteration, I is now I is now 1, isn't it? Just print out I. So yeah, I is 1. So it's done the result, which is still 1, times by the base. Which is 2.4. And then if we continue, print it out, it's going to be 2. And if we print out a result, that's going to be 2.4 times 2.4, which apparently is 5.76. Right, so I is still 2. I is now 2, and it's less than the exponent. So then, with a bit of luck, it's going to increment again. It has incremented, but it's just jumped straight out of the loop, I think. It's saying extra normally, so it's done that, and it's just calculated that. I spent all that time learning how to compare to Sonnet. Yeah, well, Rosie is a painter, so yeah. In fact, it's kind of a bit. It's my dream to get Rosie to stream her drawing and painting with narration. Yeah, that's my dream. And then all of Twitch can just yeah, just enjoy that. So I don't know if I explained that very well, but when I print out power, that's just back to that. Can I print out I? Can I print out anything more actually? 200 possibilities. Oh wow. That's interesting. Ooh. Oh, print out different main, can you? Oh, hang on a second. So print out... print out power, print out print... Can I? Interesting. I know. You trade, say, knowledge of Pascal for some aspect of drawing. Oh. Yeah, I like how drawing goes. Yeah, I'd like to be able to draw as well. Yeah. So we've kind of looked through this function. We've seen what it does. Basically the program itself, currently, how this works, right? You set up a variable, which is, just hang on a second, it's this, and you want to set power of something to be the value, the value computed by this power function. This power function. But I should really pick the whole lot. And when you call the power function, you are setting these values here. So the first argument that you pass will be the base. The second argument you pass will be the exponent. And then inside the function, you use these kind of identifiers to do the computations, and then they do the computation and they return the results, and the result is what goes in to power something. Right, and then after that, I just print f power something. So yeah, let me just have a look at the chat. I think we'll be overselling my knowledge of Pascal there, really. Be more modest. Yeah. Yeah, even to draw a cardboard box would be great. Yeah. So, let's get a bit more funky here. I'm going to do this again. Just very quickly, I can do it. Flight power something. I want to make this to be an array that's 16 big. 16 big. I want to set the base to be 12.8. Okay. So what I'm trying to do here is I'm going to make a loop. So it's going to be a for I loop again. So while I is less than the size of power of something, divided by size of a pointer to power of something, we're going to plus I. So within the loop, we will then call power of something, won't we? Power of something is going to be equal to the power I'm going to pass to that the base and I. Oh heck, hang on, I'm missing a bit of chat here. Roger, wanted to your computer units or loading time. One question, you ever drawn an asteroid floating through the void of space? Ah. Oh. Just loving this chat. So the power symbol is going to be power. Okay, so I think we have to do like that. So I do want to enclose that. So then we're going to print out it's going to be that to the power of a decimal is equal to a float. I am. Yeah, and I will need art actually. So at first, I will probably... Oh, Rosie's got to go. Rosie should probably go. Control you nothing distracting you. Don't be silly. I mean, I've said this before. I said, yeah, don't worry about distracting people. You know, you can just come in and hang out. I mean, if you've got something else to do, then sure, go for it. But you don't need to worry about distracting me, because yeah, it's just all fun, you know. I don't know. And that's just going, yeah. So what were we talking about? Let's point to streaming. Yeah, exactly. Yeah. I mean, I kind of stream so being pleasantly distracted. Yeah, that is it really. Yeah, I mean, like for the last 2 streams, right, or the last 3 streams, I've kind of just jumped in, aiming to do like 30 minutes of practicing. But I ended up doing 2 hours, partly because I was interactive with the chat. Well, actually, I'd probably say mostly because I was interacting with the chat, because you know, that kind of led on to more kind of stuff to explore. You know, I don't know if I would have done that without the chat. But I mean, also, it doesn't have to be something like, it doesn't have to be like anything to do with programming. It could just be like, I don't know, hanging out. I look cool with a beard. Yes. Thank you. Yeah, I wish I could grow in a bit thicker though. That would be kind of cool. So, power is something. So the first thing is that it passes the base to the and then it's I, isn't it? I'm pretty sure that's just it, really. Oh, float 16 is not assignable. Really? I think it might be, yeah. So yeah, that looks about right to me. So yes, I think I've done this correctly. So I'm working out the powers of 12.8 here. So 12.8 to the 0th power is 1, which for the time being, you just got to trust me on that. I did do it in maths at high school. I went into why that's the case, but there's no way I'm going to remember it now. I could just remember the fact that powering something by 0. I mean, we were looking into this the other day actually. I think we concluded that raising almost any number to the power of 0 equals 1. Right, that's about as good as we got. So it's kind of a convention, but you can also calculate it as well. So, but I think depending on the like, I don't know, depending on the mathematical model that you're using, it can be 1 or I don't know what else it can be, but yeah. So then 12.8 to the 1 is 12.8, obviously, and then it's just calculating the rest. So if I just do calc here, 12.8 to the power 3 is 2097.152. I mean, calc presumably just does 3 decimal places. Let me just see a long ones. Okay, so 2 to the power 4. So it does do 4 decimal places. But my thing is giving us more decimal places. But one thing we have to watch out for here is float precision. I mean, basically, let me just get a document up here. Floating point number. When it finally loads. What's the habitat connection? Oh dear. Let me just check drop frames. 215 drop frames. Mic's still on. Music's still on. I don't know if I can see. Let's check. I am live still. Let's check. Okay, delay. Got data I should put back. So floating point number. They use 32 bits to represent their numbers. 32 bits are 8 bytes. Sorry. 30 bits 4 bytes. But I think that's irrelevant. It's really the 32 bits of it. I think. Yeah, the total bits of 32. So a single float will reserve 1 bit for the sign. That's whether it's positive or negative. 8 bits for the exponent. Which I presume is the mantissa kind of a bit of it. Maybe. And 23 bits for the significant field. kind of bias, bits precision. I'm not sure I'll be able to describe this very well, actually. This is the kind of thing that Casey's very good at describing, because he fully understands it. But I'm not sure I'll be able to do a very good job at all of it. So I don't think I'll bother. But suffice it to say, right, okay, yeah, sorry about that. It's just the network going down. Hopefully I'm back now. It's always weird when you can see yourself, like just sitting there. Anyway, so I've done this thing. I've got the function, and I've done this loop, which loops over and shows me this. So one thing I was thinking of learning now is pointers. It's pointers, and it's also timing, wasn't it? I'm not quite sure if I can look for this. So, cycle count. Yeah, it is, isn't it? It's the RDTSC. Oh, okay. So can I just do this on Linux as well? I mean, I suppose this is a bit premature to be looking up this sort of stuff. Because optimization is something that's it's a bit later in the development process that you have to think about it. How to use mode. So CPU clock might mean more time. Didn't see I was putting rubbish out. Oh, nice. Chocolate cake for the win. What different? I can see the chat. Hmm. That's what I thought. I thought it was a Microsoft specific thing. Um, mm, mm. Uh, got some of those and crisps. Yeah, actually, you know what? I think it was Mola that I was drinking yesterday. Um, oh, 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 yeah, I think I was drinking Mola yesterday. Had like, oh wow, wow, that's an awesome cake. That's what you're saying. You're saying it's a robin, is that right? It's shaped like a robin. Okay. It looks a little bit like the Owl of Shame, honestly, but it does look good. Yeah, I had a couple of glasses out of Merlot, and I think that's one glass too many for me. Just double check that switches. Yeah. So if I build this now, I've got no idea what it's going to do. Implicit declaration of function sleep is invalid. Do I need it to sleep? Am I bothered about it sleeping? I think I'd rather... Oh, I see what he's trying to do. I mean, rather than do that, I can just do a printf, can't I? Printf equals bit of stuff. Right. And you can run this. Bit of stuff. Time in MS0. Is that milliseconds? Is that going to give us milliseconds? Because if it is, then that's going to be no better than just doing this. Hmm. Of course, what butterflies were partially consumed. So let's see, it was dividing that by that. Tick 1. I mean, that's not showing me anything, is it? Because it's just too short. Tell me in milliseconds, can I just... I don't really want that, I just want that, basically. So 0 milliseconds. Have I frozen? Have I frozen? Hopefully I haven't. Festive. Yeah, I got my festive earphones on. Headphones, rather. I mean, I suppose maybe I had frozen. Maybe I'm just not moving. I could possibly have been thinking. So let me just, I'm going to do another printf. So a bit of stuff, another bit of stuff, so that took longer. We'll just do that again. Right, Yeah, it just takes a super variable amount of time. I don't know. I don't know that... I'm not going to get much information out of this, I don't think. It's kind of hovering around that area, but... Too late. I don't know. I mean, that divide by that stuff. I mean, if I do a load of them. I mean, I know that printf is not really super. It's not really super, like, a lengthy process, is it? Let's just do this. Can I just do that? Right. Let's just do a shitload of them. Just see. So, I mean, it is kind of corresponding to longer times. In fact, I'll tell you what, it's not milliseconds at all. It's just cycles. That's all I want to see. Oops. But again, you've got the thing of the processor, like clock speed. You've got that to deal with. So yeah, I don't know if there's much. I don't know if there's much value in this at all, honestly. Short of, short of pegging the CPU up to like performance mode or whatever. So I don't know. Maybe I'll just get rid of this lot. I mean, honestly, I think it's premature anyway to be thinking of this stuff. But one thing I do need to learn is definitely pointers. That's what I need to learn. Yeah, I mean, I just kind of copied and pasted that, honestly, so I didn't fully grok it. It's nice that I know that it's possible. Include system time. Hi Rosie, welcome back. Yo, Mr. Fourth Dimension. Always an honour to have you in my stream. All I've done so far is very similar to the past few days. All I've done is written this function and filled an array with the output of that function. And today the number is 12.8, because I just picked that randomly. But one thing I did just do was I was just timing like hang on a second. What was it? Cycles. I think this is probably right. Yeah, I just did a whole load of printfs. So yeah, I did 2020 printfs just to time it. And I was finding that it is taking that number of cycles on that time through, and then it's taking that number of cycles on that. I just find it is very variable because of this. The clock speed. Toggle linear pointers. Yes, that's what I'm going to do. Yeah, toggle linear pointers. Yeah. So, that's what we're doing. Okay. Just check that. Yeah, we're back to there. So yeah, pointers. That's Barry Jake's cake that he's currently consuming. Pointers, dreaded pointers. Right. These printers are a frivolous program. Set up the pointers to the start of the arrays. Was pretty concerned. Yeah, totally. That's kind of as I understand it too. So, if we've got an array here, or a float thing, current age. So presumably ages here is an array. Yep. Yeah, it is an array. So it's going to have an int pointed to the start of it. Mind you, these are all ints as well. So I'm going to guess that I need to make this actually a float. Oh gosh, what's happened to my... Have I lost my... Oh, hang on a second. I know what it is. I've got paste on. Yep, let's mark it. Okay, so we're going to have a pointer. We're going to make a pointer to power something. Let's say particular power. It's going to be equal. So it's a pointer particular power. Equal power something. Yeah, I know that my webcam's kind of up in this area. There's nothing not really covering everything there. Set up the pointers to the start of the arrays. I think we just stick with one array for now, maybe. First we're using indexing. That's what I've done, isn't it? So the second we're using pointers. Okay. Let me see then. For int I equals 0, I is less than the... It's like just this again, isn't it? Actually, the whole lot is the same, isn't it? All of this is the same. And this is populating the this is actually doing the populating of the array. And then the printf is string is decimal years old. So pointer cur age plus I. So it's in particular plus I. Is that what we're saying? What we had built. Okay. Farewell from Eris, it's nice to see you here, and hope it wasn't too boring. Hope you enjoyed it. Hug Rosie goodbye. So here, this is a pointer to particular power plus I. I wonder what happens if I don't do the plus I. I think a lot of my early computer pointers was born out of not really understanding properly what a variable is. Always learning materials talk about storing values in variables and gloss over what is really happening. Storing values in variables. Oh, I thought it was interesting, Rosie. Okay, so I think actually, Fiery, you asked me the other day if I've learnt variables, and I said that I hadn't really, but that I roughly know what they are. So what I think is happening, I don't know if I should really just assume or whether I should actually go and learn them, but say like you do this here, you did a float base equals that. You are reserving some space on the stack that is the size of a float, which is 32 bits. And you're going to give it the name base that you'll be able to use in your program. So in this scope here, so this is all in the same scope. I mean, if I was to, I can printf base down here, I should imagine. What is it? Float, isn't it? So I can do that. Because almost perfect, I would say. Don't know what I've done there though. The same format. I suppose type car star, but the argument has base. The base is 12.8. Oh, mind you, I've got all this. I've got that stuff in between, haven't I? Why should that get in the way? Oh, sorry, it's a blooming flow, isn't it? Yeah, wake up, dude. I think. Base is then goes to the content of that memory location, which is interpreted as a float. That's indefinitely said in this principle. Okay, base is the name given to the content of that memory location. Right. And that memory location being that, right? So, blimey. In fact, I'll just put another new line there, just so it's clear. So it's a base, because it's still in the same scope, right? Base prints out as 12.8, which is set there. And the location of that is there. So we've dereferenced that. Distinctly that float pointed to base P equals to the register base P. Yeah, given the location, we'll be given the location in memory. Base, and then base P. Right. Okay. So, okay, let's just try this then. What have we got? I've got that particular power. Well, I mean, I'll tell you what. Let's just do this. Sorry, I muddled it a bit. Float base P equals to the address of base. That makes sense to me. And then if I was to printf that, it will actually probably be a float, won't it? Oh no, it'll be an int, probably. Well, it's a hexadecimal value, isn't it? I'll check float. Okie dokie. So do you have to make it a P then? Float HP is equal to the pointer. Oh yeah, because that is a pointer. What's it that the address of base is the name you give to the location of the memory containing base. Location of memory containing base. Is that true? Because that's dereferencing basically something slightly different. Okay. So printing off. I mean, I think as I understand it, hang on a minute. That is. Can you actually declare a variable? That is a. That's an address. Something slightly different. It is another bit of stack allocated memory that can contain a memory pointer. And you store the address of the memory containing base into that location. So a memory pointer is a type, is it? You store the address of the memory containing base into that location. Yeah. What I was just wondering was if you can do this. Oh, mind you. So if this is going to be an address, it's got to be of the form this, basically, isn't it? Oh yeah, that's a great thing about Vim, is that you can like increment by hex. Like, watch this, you can do that, and it just does that. Keep on going. Very cool. Yeah, Mr. Foster mentioned if you're looking for a feature to implement in 4Coder, this is the one I'd request. It is incrementing numbers. So I'm pressing Alt, Control and A to increment upwards, and Control and X to decrement. And it knows that it's a hex number, presumably because of that. And you can like sit anywhere you like, start from there, but it'll jump to the end to start incrementing. So yeah, that's something I use in the while doing the annotations. Actually, I use that quite a bit. One thing that would be great actually would be if it can identify that the number is a time. So something that's off the format, like number colon number, and that as you get up to 59, it would then wrap to 0 and increment the minute number. If it could do that, that'd be great, but it doesn't. So, well, that's not too hard. Awesome. That is not valid in a C type. I mean, something C. Ah, right. Yeah, I kind of hadn't got that, had I? In fact, I'll just change the name of this. I'll just basic. Mind you, basic P. Would it need a variable called basic P? I wonder. Yeah, it's expect to identify. So basically you can't. Yeah, like you're saying, you can't do that. But if you were to do, you could set the pointer to that to be this, right? Oh, interesting. you do that plus 8? I'm just thinking of yeah, you can do that, can't you? Kind of. Ampersand is a kind of special operator. Okay. Yeah, I think I did actually spot something about that. So it's the C ampersand operator. Kind of means the address of. Oh, okay. Hmm. Yeah, I mean, the 2 ampersands is equal to like and, so if this and this. That's bitwise and, yeah, it's that, isn't it? It's the and as well, which I haven't quite got to yet. So you say, when I say base, I'm referring to the content of that memory that backs base. Yes, but ampersand base is the address where that memory, the address where in memory. Yeah. Yeah. Okay. It's not that. I'm sorry, no. That's something else, isn't it? Yeah, I mean, I suppose. I suppose an analogy would be sort of saying, if I was to try and do float, I don't know, a float plus whatever. There's unary ampersand, i.e. one operand, which is addressed, yeah. Binary, which is the and thing. How can you do this? I wonder. There's binary, which is bitwise and. Bitwise and. I mean, this was saying that bitwise and is 1. Oh, sorry. Right. So, 2 operands. Right. The unit operator is minus. Right. Oh, right, yeah. Whereas minus base would be decrementing base. Is that right? Oh, right, okay. Let me just have a look at this. So there's another example of unary operator is 1 minus sign, i.e. minus base. Maybe that one becomes address of, okay. And that base. Yeah, interesting. So So how can I use that unary operator? Unary minus. Oh, of course, yeah, it's just negating it, isn't it? It's like saying zero. Hang on a minute. No, would that be right? Because then in some ways it's like saying 0 minus base, but is that quite what you mean? Hang on a minute. Something off. And it's probably a what's this, float, isn't it? So minus base. Base negates 0. Oh, okay. Alright. And then doing it to both sides. Because I mean, I suppose what just went through my mind there is that where this is different from the unary ampersand one. How many unary places? Okay. Yeah, where is this different from the unary ampersand? Although maybe you could kind of say that. I mean, you could kind of say, you could think of it like the unary ampersand base is going to be like 0. It's just going to be memory address 0 plus the memory address of base. Maybe you could think of it like that. So you've got exclamation mark, which is not. Good evening, purposely drifting. Good evening, good to see you. Tilde, minus plus, plus plus and minus minus. Confusingly, a star can also be used for a unary operator. Casting is treated as unary by some. Right star and ampersand. Right. Okay. I think I understand that. I mean, I suppose that's something I could potentially do, actually. I haven't actually done a cast yet. So for a bit of fun, I could just... it's like I wanted to cast base P to an int. Can I just cast it here? Oh, right. Got you. Is this how you cast? Oh, it might be. Although, what am I trying to cast here? I'm trying to cast a pointer to that. Let me just actually try and cast something else. Let me just try and cast a float. Pretty sure it's in case you just do that. So, dereference is the opposite of that. So that, oh wow. So that is just base. Oh, okay. So, I'm trying to cast this to an int, right? Interesting. Yeah, pretty much. Yeah, we are going over pointers. And then I've just taken a little detour into casting. So that base P is to reference. Actually, Can I just do that? I wonder. Understanding types is closely related. Oh, this is interesting. So we've got a hex value of 1. What does the type actually mean? Okay. So if we say that a type is an int or a float or now a pointer, what does making it a pointer type mean? Making it a pointer type, which is what we're doing here in this line. So this is a pointer type. Although why it's a float, I'm not 100% sure. Could it just be an int? And am I even doing it right? Incompatible pointer types initializing int star. Int 1 something but otherwise type printf. D base p. Oh, hang on a minute, and base p itself actually. Previously done that. No, the only place that we've used base p is those two places. So does that mean I need to do something like that? No. So that has worked. Oh, now I've got a floating point number. Interestingly enough. So what does making it a pointer type mean? So, like I was going to say, this is making it a pointer type. I kind of want to say, does making it a pointer type not reserve any space on the stack, but it just so making this right, making this float add equals minus base. So we're specifying that this type is a float called add. So we are reserving a float's worth of space on the stack, and we're going to refer to it by the name add in our own code. And we're going to assign to it here the value of minus base. Oh right, yeah. Why was it? Okay, so Mr. Foster mentioned to get up on. Right, up at 10. Okay. Well, I won't go too much longer then. In fact, the music is finished as well. Yeah, the music's finished, so I should stop very soon. And yeah, I mean, I don't need to actually fully learn this today, because I will be practicing daily as much as I can. So I don't need to fully 100% understand it. But I'll just finish what I'm saying. Specifying this float add. We've reserved a float's worth of space on the stack, and we're going to refer to it by the name add in our program. And here we're going to put the value of minus base into that location, into that space that has been reserved, making it a pointer type. A float's worth of space and using that variable will interpret the bit stored as a particular kind of encoded number. The Hamilton says, but okay. Oh right, yeah. And using that variable will interpret the bit stored as a particular kind of encoded number. Yes. Right. So like if it was an int, we reserve that space and we'll interpret that instead of the bit stored there as an integer, whether it be signed or unsigned, and also the width of the int that you're talking about, whether it's an int 32 or an int 16. But a pointer, are we going to reserve that space? So we're casting a float to an int. Okay, so casting a float to an int means, watching the timer. I mean, you've got to dispense with the stuff after the decimal place. Yeah, you're basically kind of casting a float star to an int star means. Wow, this is some serious drama here, Fiery. The tension is pretty unbearable. Casting a float means. Hang on a minute, am I supposed to be answering this, or are you actually going to answer it? Oh no, what's happened? What have I done? I'll wrap it up very soon. These are just questions for. Oh right, okay, got you. So casting a float to an int means it's changing how the value is going to be interpreted. So rather than interpreting those bits as a float, you interpret those bits as an int. And presumably the cast call, when you call cast, it actually works out how to change the interpretation. So like the floating point number was like 1.327, right? 1.327 float. When it casts it to an int, which is actually what casting a float starts when it's okay. Oh, right. That's the float start. It's different things, is it? Float start and int star. Casting a float. So if that's casting a float start and int star, is changing how it's interpreted, and casting a float to an int. I think what that is to be left until another day. Yeah, it should give 3. Yeah, that's what I'd understand. That's the point actually, because it's not. Where was my cast? I miss my ampersand in there. My cast was it was that, wasn't it? So you just do an int to minus that, is it? Let's just see. I need to actually print that out. Oops. Oh god. I'm printing out an int. Add. Minus 12. Yeah, so it's just chopped off the, it just chops off the decimal place bit, doesn't it? Yes. Float equals point equals register int. Oh blimey. Okay. I think we're gonna have to call it there, guys. I don't want to just delay Mr. Fourth Dimension stream any longer. I totally missed what Purposely Drifting was talking about. Been picking up float power methods. Oh right. And we find that many compilers are no longer handling the int32 want to go to float direct bit by bit copy. Oh, okay. Well, yeah. Okay. I'll call it there. And I'll have done again. I've done another an hour and 47. There's me again. Hi me. An hour and 47. Yeah. So that's it, folks. That's all, folks. As they said. Tomorrow, I think we're going to continue with pointers. We still have to do Purposely Drifting's crazy thing. It was, where was it? It was this. We still need to look at this. Absolute madness. I'm going to be copying out this stuff into my little thing and just seeing if it runs. So this compiles with GCC. We want to find out if it compiles with Clang. So yeah, I think maybe tomorrow, rather than starting with the function and all that kind of stuff, the power function, I think I'll just start off by doing this, see if it works. And then possibly kind of try and understand what's happening. It's probably worth understanding it. And then, yeah, that's it. No worries. So, yeah, we're off. over to Mr. Fourth stream, folks. Bye.